In this video, we will learn about the measures of the angles that are formed when a pair of lines is cut by a transversal. In this figure, L and M are non-parallel lines and P is the transversal that cuts across it. And we have the 8 angles numbered from 1 to 8. Now let us use a protractor to actually measure these angles. We can see that angle 1 measures 110 and 2 is 70. Now 2 and 4 are vertically opposite, so they are equal in measure. So the measure of angle 4 is 70. Same is the case with 1 and 3. They are vertically opposite, hence equal. Now let us measure angles 5 and 6. Angle 5 measures 120 in this figure and 6 measures 60 degrees. If we apply the same logic, 6 and 8 are vertically opposite, hence equal, and 5 and 7 are vertically opposite, hence equal. So this is an example of angles formed when the lines are not parallel. But when the lines become parallel, we see something very interesting. Let us draw a second figure where L is made parallel to M. And let us keep the same transversal. In this second figure, we will rename the lines as L dash, M dash and P dash. Now if we measure angle 1 and 2, we will see that 1 is 120 and 2 is 60. Again, when we apply the same logic of vertically opposite, 4 becomes 60 and 3 becomes 120. When we measure 5 and 6, they are still the same. 5 is 120 and 6 is 60. And by virtue of being vertically opposite, we have 8 and 7 as 60 and 120. If we observe the pairs of angles that are formed when this transversal cuts these parallel lines, we will see something very interesting. Let us start by looking at all the corresponding angles in this figure. 3 and 7 are corresponding. We can see that both of them are equal in measure. Both measure 120 degrees. Is this valid for all corresponding angles? Let us look at the second pair of corresponding angles, 4 and 8. We can see even these angles are equal to each other. They are both 60. The third pair is angle 5 and 1. They are also equal to each other, both measure 120. And the fourth pair is 2 and 5. Are these equal? Yes. So we can conclude that when a set of parallel lines is cut by a transversal, all the corresponding angles are equal to each other. That is, within a pair, they have equal measures. 4 and 6 are alternate interior, and so are 3 and 5. They are also equal to each other. So alternate interior angles are equal in measure. What about the co-interior? 4 and 5 are co-interior. They are not equal, but their sum is 180. And so is the case for angle 3 and 6. Their sum is 180. So we say that the co-interior angles are supplementary. In fact, these properties hold true for any pair of parallel lines that are cut by a transversal. The corresponding angles and the alternate interior angles are always equal, and the co-interior angles are supplementary. In fact, we can use these properties to find out the measures of angles that are missing. Suppose we are given a pair of parallel lines which is cut by a transversal measure of any one angle. We can actually find out the measures of all the remaining angles just by knowing one angle. Look at this figure. In this figure, 1 measures 45. Now can we figure out all the other angles? 3 is 45, this is straightforward because 1 and 3 are vertically opposite. Can we find out 2? You see 1 and 2 form a linear pair. So their sum should be 180. So 2 is 135. Now 2 and 4 are vertically opposite. So it's easy to estimate 4. Now what about 5? Can we find out the measure of angle 5? We have just now seen that corresponding angles are equal. Now 1 and 5 form a pair of corresponding angles. Hence, we can say phi is equal to 1, which is 45. But 3 and 5 are alternate interior, they are also equal. Or 4 and 5 are co-interior, so they are supplementary. Hence, we can find out 5. So, we can find out this angle in many different ways. And once we get one angle, finding the rest of the angles is very easy. We just use the properties of vertically opposite and linear pair to get all the remaining angles. Over here, 6 and 8 are vertically opposite, hence equal. So we have found all the angles.